Hello. In 8086 microprocessor, some pins provide some signals in maximum mode and the same set of pins provide different types of signals in minimum mode. In this video, I am going to discuss the functions of such pins. In 8086, pins from 24 to 31 provides some functions in maximum mode and the same pins provides different functions in minimum mode. To remember the names of the pins in both modes, I have coined some sentences. Just observe it. To remember QS1 and QS0 and S0, S1, S2, I am using these two sentences. I will ask two questions, QS0, QS1, with three options for each, S0, S1, S2. You have to log the answer. Depending on the answer, you will be requested to go to either gate 1 or gate 0. Now you observe this, QS0 and QS1, two questions. These are the three options. You have to log the correct answer. Based on the answer, you will be requested or queue to go to either gate 1 or gate 0. So, by remembering this sentence or situation, you will be able to remember the names of all these pins. These are the functions performed by these pins in maximum mode. Similarly, in minimum mode, the same pins will perform these functions, that is interrupt acknowledge, ALE, that is address latch enable, data transmit or receive, then memory or IO, then write, hold, acknowledge, hold. To remember the names of these pins, you remember this sentence. The interruption was acknowledged by Mr. Alauddin and the dispute was resolved, maximizing IP value, intellectual property value, and written acknowledgement was provided to hold the rights. So remember this situation and remember the sentence. Now you see, interrupt acknowledge is an active low signal, so a bar should be provided like this. That is the first signal. Then second one is ALE. You remember Alauddin. Then next pin is DEN, but here DEN is there. Alauddin may represent ALE and DEN. Then dispute was resolved. That means DT and R. This is data transmit, this is data receive. Maximizing IP value. So M is here, so this is M, IP, I is there. So you remember that M bar IO. Actually, this M is for memory, this is for IO port. And return, write signal. Acknowledgement. Actually, this acknowledgement is provided as hold acknowledgement. Next signal is hold, to hold the rights. So read this sentence, try to remember the situation and sentence. From that, you will be able to write the names of all these pins. The first difference between minimum mode and maximum mode is for minimum mode, this pin 33 should be connected to high, that means plus 5 volt. For maximum mode operation, this pin should be grounded, that means it should be connected to 0 volt. The minimum mode signals and maximum mode signals are different for these pins, that is pin number 24 to 31. In the maximum mode, pin number 24 will act as QS1 and in minimum mode it will act as interrupt acknowledge. Actually QS0 and QS1 are the status of the instruction queue. This status indicates the activities in the queue during the previous clock cycle. When QS1 and QS0 both are 0, then Q is idle. If QS1 is 0 and QS0 is 1, then first byte of the opcode is from the queue. QS1 is 1 and QS0 is 0, then Q is empty. If QS1 is 1 and QS0 is 1, then subsequent byte is from the queue. In the minimum mode, pin number 24, that is QS1, will act as interrupt acknowledge signal. The interrupt acknowledge signal is made active, that is, it is made 0 when the interrupt line of 8086 goes high. Similarly, this QS0 will act as address latch enable in minimum mode. This address latch enable signal is used to latch the lower 16-bit address because these lines are multiplexed with 16-bit data. The pins S0, S1, S2 indicates the type of the machine cycle used for the current transfer in maximum mode. If these signals S2, S1, S0 all are 0, then it indicates that the processor is issuing an interrupt acknowledge signal. If it is 001, the processor is issuing a read IO port signal. If 010, then write IO port. If these three signals S2, S1, S0 are 011, then it indicates a halt operation. If S2 is 1, S1 is 0, and S0 is also 0, then it indicates that code segment is accessed. If it is 101, it indicates that the processor is reading the memory. If the signals are 110, then write memory. Then if all are ones, it is in passive state. In minimum mode, the pin number 26, that is S0 bar, is changed to DEN, data enable signal, which is used along with data transmit pin to enable the transceivers. The next pin, that is S1, that is pin number 27, acts as data transmit or receive. A high in this signal indicates that the processor sends or transmits data to memory. So transmitting means from microprocessor to memory or IO port. Yellow on this pin indicates that the processor receives data from the memory. That is, the data transfer is from memory to microprocessor or from an IO port to processor. This signal or pin number 28 will act as memory or IO port indication signal. The processor makes this pin high when it is transferring data from the memory, and the processor makes this pin low when it is transferring data from the port. The pin number 29 acts as lock signal in maximum mode, and it is acting as write signal in minimum mode. When this pin is low, the buses are locked so that other processors cannot use the bus. In the minimum mode, the same pin is generating write signal, which will help to write the data on the memory or IO port. Pin numbers 30 and 31 acts as request and grant signals in maximum mode. These pins are used to exchange buses between processors. So the buses may be used by 8086 processor, or it may be used by the coprocessor. So these things will be synchronized using this request and grant bus signals. Pin number 30 is acting as hold acknowledge signal in minimum mode, and pin number 31 is acting as hold signal in minimum mode. If you use a DMA controller, then hold and hold acknowledge signals are used when the DMA controller wants to get the buses from 8086. When a DMA controller is connected to 8086 in minimum mode, these two signals will be used by the DMA controller. These are the differences in pins. Then some other differences we may point out, that is, in maximum mode, the performance is high because it allows multiprocessing. Actually, here 8087 math coprocessor or 8089 IO processor can be connected with the 8086 in maximum mode. But in minimum mode, multiprocessing cannot be done. Only one single 8086 processor performs all the operations. So the performance will be low. Then in maximum mode, the signals S0, S1, S2 are decoded by a bus controller to produce memory read, memory write signals, or IO read, IO write signals. But in minimum mode, memory or IO bar, read bar, write bar are generated by the 8086 processor, and they are decoded by 3 to 8 decoder to decode it as memory read or memory write or IO read or IO write operation. An 8288 bus controller generates all the control signals like ALE, data transmit or receive signals in maximum mode. But in minimum mode, the 8086 processor itself is generating all the control signals, that is ALE, data transmit or receive or data enable. So the bus controller IC is not needed in minimum mode.